We're going to move on to sign diagrams. So this is just a review of increasing and decreasing slope. So example 6 just shows you A, B, and C all have positive slopes at them. And then at D, the slope is 0. That's going to become important later on when you have a slope of 0. So at the maximum point and the minimum point of a function, the slope is going to be 0. It's extremely important to remember that the derivative is always 0 at those maximum minimum points. So you can just talk about when you have a function that's increasing, the derivative value is going to be greater than 0. When it's increasing again, the derivative value is going to be greater than 0. When it's decreasing, the derivative value is going to be a negative. All right, so we're going to be creating sign diagrams. So this I just took from your book. We're going to be focusing on sign diagrams, the critical value, so that we can then find out what might be the maximum or minimum point of a function. So I've laid out some steps for us. Step 1 is we want to find the derivative of the function using our power rule. Step 2 is we want to find the critical values for which the function equals 0. So we are going to be doing some factoring here, so think back to Wonderful Algebra 2. And then we're going to set up a sign diagram, and we're going to test points on the left and right side of these critical points and find out when is the derivative positive or negative. Then we'll be able to draw a rough sketch of this function when it's increasing and decreasing, and then we'll write our answers as intervals. All right, so here's our example. Find the intervals for which this function increases and decreases using the sign diagram. So here's our function. It is a cubic function. So the shape, if we think of it visually, is like a snake. So we're going to find the derivative first using our power rule. So we'll bring down that 3, subtract the power. Bring down the 2, subtract the power. Bring down the 1, subtract the power. And now simplify it. So 6x squared plus 6x minus 12. So there's your derivative function. Now step 2 is we want to find the critical values, critical points for which this derivative will equal 0. And then we're going to solve it for x. So we're going to set this derivative equal to 0. So here's our derivative. We're going to set it equal to 0. So 6x squared plus 6x minus 12. Set it equal to 0. And now we need to find out the x value. So we're going to factor it. So one of the methods of factoring is look for a greatest common factor. So the greatest common factor is we can divide out 6 from all of the terms. Now we're going to go inside of that parentheses, and it's a quadratic. So we're going to look for factors of -2 that add to +1. So those are +2 and -1. Now we have it factorized. So we're going to set those factors equal to 0 and solve for x. That's called the zero product property. So here's our first factor. We set it equal to 0. We solve for x, and we get -2. Set the next factor equal to 0. Solve for x, and we get 2 answers. Therefore, the critical values are at at x equals -2 and 1. All right, step 3 is we're going to set up a sign diagram using those critical values. And we're going to evaluate the derivative with test points between the critical values. When the derivative is positive, it's going to increase. When that derivative value is negative, that interval is decreasing. All right, so setting up our sign diagram. So remember our critical points. We're at -2 and +1. Critical point, critical point. And now what we're going to do is we're going to test values around the critical points. So here's -3, here's 0, and here's 2. So I'm going to test a point somewhere in this region. So I just chose -3. You can choose any number less than -2. And what you're doing is you're substituting it into the derivative function. So let's go back. Who's your derivative? This is your derivative function. You're going to be evaluating it multiple times on either side of those critical points. So here we go. So I'm just going to write the derivative function down for you. So here's our derivative function. 6x squared plus 6x minus 12. All right, so we're going to start with -3. We want to see when we evaluate the derivative function, are we going to get a positive or a negative value? So substitute -3 into the function. Do our orders of operation PEMDAS. -3 times -3 is +9. -18, -12. Continue simplifying. 54 minus 18 minus 12. What do we get? 24. So what this is saying right here at -3 is the slope of that interval is a positive number. Should be -3. So this entire region, everything to the left of that critical point is increasing. So if this is my critical point at -2, this graph is increasing something like this. Now what happens is it tapers off because this is the derivative right there when it equals 0. So the slope is 0 here. So it is increasing. Okay. All right, so now we're going to test a point between -2 and 1. So I just chose the number 0, somewhere in between there. And we're going to evaluate the derivative function. All right. So evaluate the derivative function. Well, the first two terms become 0. And then we get -12. So this is our slope between those critical points. That's a negative slope. It means it's decreasing between those critical points. So between -2 and 0, it's decreased, or -2 and 1, it's decreasing. The slope throughout that interval is negative. And then what happens is now the slope is 0. at 1. Now what's going to happen? Is it going to continue decreasing, or is it going to go back up? So we want to test one more time. So I just chose a number to the right of that critical point, so 2. Let's see what happens. So we're evaluating the derivative function at 2. Simplify it, do your orders of operation. 2 squared is 4, 6 times 2 is 12, 6 times 4 is 24, plus 12 minus 12 gives you 24. Positive number. Slope is positive. So what does that mean? It's increasing. So what's happening? From here, it's going to go back up. So there's a rough sketch of our sine function. So, sorry. So this is a positive, a negative, and a positive sine. This is where it comes from the sine diagram. So this is telling me this interval is increasing. This interval here between the critical points is decreasing function, and then it changes again to an increasing function. All right, so to continue on, step 4, draw a rough sketch of this function. I mean, this is rough, so here's -3, here's -2, -1, 0, 1, 2, 3. Remember those critical points were at -2 and +1. Those were your critical points. So that's where your sign changes are going to go from a positive to a negative slope or a negative to a positive slope. So what happens is it's increasing up to here, and then it has to change direction to a negative slope, and then increases again. Rough sketch. This is going to be where a maximum point is going to occur, and will be a minimum point is going to occur. Step 5 is to write your intervals for which it's increasing and decreasing. So, where is it increasing? It's increasing from negative, so I'll highlight this in purple. This piece is increasing, it has a positive slope. So that's -infinity, comma, to where it stops on the x-axis, -2. And then it increases again at 1 to infinity. All right, and then here in the red, it decreases. What is that interval? It's always the x-axis from -2 to 1.